Welcome to Wisdom Outlined Coaching. My name is Askar Khan, your math coach. In this video, we will learn about number facts and rational and irrational numbers. So let's dive into the lesson. Let's understand what is a number line. A number line is basically, you have a line, 0 is in the middle. On to the right of 0, you have all positive numbers. 1, 2, 3, 4, 5 and goes on. On the left hand of 0, you have all the negative numbers. -1, -2, -3, -4 and so on. This is a number line. Okay. Now all the numbers that begin from 1 and upwards, they are called natural numbers. All the numbers that begin from 0 and go on in the positive direction, they are called whole numbers. And all the numbers that are negative, positive and including 0, they are called integers. Some textbooks say whole numbers are also negatives, 0 and positive. But generally, integers are all the negative numbers, 0 and all the positive numbers. 0 is neither positive nor negative. Fine. A quick question. Think about it and answer. All whole numbers are natural numbers. True or false? It's false. Good. Because all whole numbers are not natural numbers. Because 0 is a whole number, but it's not a natural number. All natural numbers are integers. True or false? True, because all natural numbers fall within the category of integers. Now, do you understand what integers are? All the negatives and the positives, including the 0. What are natural numbers? Numbers starting from 1, 2, 3, 4 and so on. What are whole numbers? 0, 1, 2, 3, 4 and so on. So this is the basic understanding of a number line. Now let's move on to some of the other facts about numbers. Let's understand what do we mean by multiples of a number. Let's take for example a number 4. Now when we say multiples of 4, it means that all the numbers that come in the multiplication table of 4. Let's list a few of them. For example, 4 times 1, 4. So 4 is a multiple of 4. 4 times 2, 8. So 8 is a multiple of 4. 4 times 3, 12. So 12 is a multiple of 4. Are you getting it? 4 times 4, 16. So 16 is a multiple of 4. Can you give me 3 more? 20. Good. 24. Okay. 1 more. 28 and so on. So these are called the multiples of 4. A quick try. Can you give me what are the multiples of 12? First 4 multiples of 12. 12 times 1, 12. 12 times 2, 24. 12 times 3, 36. 12 times 4, 48. Do you get the idea what we mean when we say multiples of a number? Great. Let us understand what we mean by factors of a number. Let's take a number again, say for example 4. Okay. Now, when we say factors of 4, it means all those numbers that can divide 4 completely, meaning the remainder has to be 0. Now, what are the numbers that can divide 4? 1, of course. 1 can divide all the numbers. And then 4 can be divided by 2. So 2 is a factor of 4. And of course 4 can be divided by 4 itself. So 4 is a factor of 4 itself. So now do you get the idea? What are the factors of a number? All those numbers that can divide the given number. Let's give a try. What about 12? Can you list all the factors of 12? In other words, all the numbers that can divide 12. 1, good. Then 2 can divide 12, so 2 is a factor of 12. Okay, go on. 3, very good. 3 can divide 12. Okay, 4, good. Then 6, because 12 can be divided by 6. And then 12 itself. Now, do you get an idea? What are the factors of a given number? In other words, all the numbers that can divide the given number that we are talking about. Great. So we understand what we mean by the factors of a number. Let's understand what are prime numbers. Now, a prime number is a number that can be divided by 1 and the number itself. No other number should be able to divide this number. For example, 2. What are the numbers that can divide 2? 1 and 2 itself. There is no other number that can divide 2. So 2 is a prime number. You get it? Now the numbers that can divide a number, they are also called as factors, as we studied in our previous slide. Okay, what about 3? Is 3 a prime number? Yes, because the only numbers that can divide 3 are 1 and 3 itself. So 3 is a prime number. Okay, a quick question to test your concept. Is 4 a prime number? Think. No, because 4 can be divided by 2, some other number. So therefore 4 is not a prime number. You get the idea now? Okay, can you list few more prime numbers? Remember one more thing, 1 is not a prime number. That's an exception. 1 is not a prime number. Keep this in mind. Okay, we have 2 as a prime number, 3 as a prime number. What about 5? The only numbers that can divide 5 are 1 and 5 itself. So 5 is a prime number. Now, go ahead. List few prime numbers. What about 7? Yes. What about 11? It is a prime number. 13, prime number. What about 17? It's a prime number. Do you think 18 is a prime number? No, because 18 can be divided by 6. It can be divided by 3. So it's not a prime number. Okay, continue. Any other prime numbers? 19, good. 23, and so on. There are many more. So now you get the idea of prime numbers. A number that can be divided by 1 and itself. That's it. and exception, 1 is not a prime number. So these are prime numbers. You will be using these when you learn prime factorization, finding LCM, finding HCF. Great. Let's move ahead. Let's understand what is a square number. A square number is a number that is multiplied by itself. For example, 2 when multiplied by itself, 2 times 2 is 4. So 4 is a square number. Get it? Okay. For example, 3 multiplied by itself, 3 times 3, 9. So 9 is a square number. So can you list few square numbers? What about 16? Is it a square number? 4 times 4, it is 16. So 16 is a square number. Fine. 25. 5 times 5 is 25. So 25 is a square number. Go on. 36. Good. 36 is 6 times 6. What about 49? Is it a square number? Yes. 7 times 7. 49. Okay. What about 63? Do you think it's a square number? No, because no number multiplied by itself is 63. 8 times 9 is 63, but that's different. It's not a square number. So do you get an idea? Oh, 8 times 9 is 72. Sorry, not 63. Fine. Go ahead. Figure out. What's the next square number after 49? 64, right? And then 81. 9 times 9, 81. 10 times 10, 100. Now, do you understand what square numbers are? Numbers multiplied by themselves. They are called square numbers. What do we mean by a cube number? A cube number is a number that is multiplied by itself 2 times. For example, let's take 2 again. If I multiply 2 by itself 2 times, so basically it's 2 into 2 into 2, which is 8. So 8 is a cube number. Get the idea now? It's very easy. Okay, let's try. What about 3 times 3 times 3? How much is it? 3 times 3 is 9. 9 times 3 is 27. So 27 is a cube number. Get the idea? What about 4 times 4 times 4? 4 times 4 is 16. 16 times 4 is 64. So 64 is a cube number. Get the idea? What about 125? Is it a cube number? Yes, because 5 times 5 times 5 is 125. 5 times 5 is 25. 25 times 5 is 125. So a cube number is basically multiplied by itself twice. So 2 times 2 times 2 is 8. So 8 is a cube number, and so on. There are many more cube numbers. So you get the idea of what a cube number is. Let's understand what are indices. Indices is nothing but writing a product in a very neat way as powers. For example, 2 times 2 times 2 times 2. Instead of writing like this 4 times itself, we will simply write the same thing as 2 to the power 4. That's what it means. 2 to the power 4 means 2 times 2 times 2 times 2. So this is called written in the form of indices. Of course, we have a different lot of laws on indices. Keep watching my videos, subscribe to my channel. We will study the laws of indices in detail. But for the time being, what are indices? It's a neat way of writing products as powers. Okay, can you write down as indices 3 times 3 times 3? Let me write down this like this. Can you write down this as in the form of an indices as a power? So how many times is 3 multiplied by itself? 1, 2, 3, 4, 5. So how will I write this as a power? 3 to the power 5. Get the idea now of how you write indices. Instead of writing 3 5 times itself, we simply write 3 to the power 5. Okay, can you tell me, think about it, what will 5 to the power 3 be equal to? Think. Do not make a mistake. 5 to the power 3 is not 5 times 3. Do not make this mistake. 5 to the power 3 means 5 times 5 times 5, which is, of course, 5 times 5 is 25. 25 times 5 is 125. So do not make the mistake of thinking 5 to the power 3 is 5 times 3. That's wrong. So now you have an idea of what indices means. Great. Let's move on for knowing more number facts. Let's understand what do we mean by the reciprocal of a number. Reciprocal of a number is nothing but 1 divided by the number. In other words, it can simply be remembered as flipping the fraction. That's all. For example, let's look at the number 4. Can I write 4 as 4 over 1? It is the same thing. Now, reciprocal means flip the fraction, 1 over 4. This is the reciprocal of 4. Okay. What is the reciprocal of 1 over 4? It is 4 over 1, which is same as 4. You get the idea now? Reciprocal is nothing but 1 divided by the number. In other words, simply flip the fraction if you don't want to be too mathematical. Okay, make a guess now. Think. What is the reciprocal of 3 over 4? Think about it. Flip the fraction. It's 4 over 3. Very good. What is the reciprocal of 6 over 9? 9 over 6. Good. Okay, now think carefully. What is the reciprocal of negative 2 over 3? Think. Did you say 3 over 2? What happened to the negative sign? Reciprocal does not mean making the signs change. The sign will still remain the same. You will only flip the fraction. That's it. You understand? So don't change the sign. The sign remains the same. Nothing happens to the sign. So negative 2 over 3 is negative 3 over 2. So you get the idea of what reciprocals are. We will be using reciprocals, indices, all these number facts that you are learning when we later solve little complex problems. Okay? So get the basic idea, understand the fundamentals. It is only then that you will be able to apply into complex problems and solve them. So know your concepts well. So we got the idea of what a reciprocal is. Good going. Let's understand what are rational and irrational numbers. A rational number is any number that can be written as a fraction where the numerator is an integer. You know what integers are? And the denominator is also an integer. And of course, the denominator cannot be equal to 0. Why? Why can't the denominator be equal to 0? That is because dividing by 0 makes no sense. It's undefined. That's why. So, a rational number is a number that can be written as a fraction where the numerator and the denominator are both integers, but the denominator cannot be 0 because 0 is also an integer. So that's an exception for the denominator. Okay, so if this is the definition of irrational numbers, quickly tell me 3 over 7. Is this a rational number? Yes, because is 3 an integer? Yes. Is 7 an integer? Yes. So 3 over 7 is a rational number. Great. What about negative 5 over 4? Is this a rational number? Yes, it is a rational number. Because negative 5 is an integer, 4 is an integer, so a fraction where numerator and denominators are integers is a rational number. So this is a rational number. Okay, what about 1 over 2? It's a mixed fraction. Is it a rational number? Do you know how to change a mixed number into a fraction, an improper fraction? You have learnt in your lower grades. 2 times 1 is 2 plus 1, that's 3. So this is nothing but 3 over 2. So therefore this also is a rational number. What about 2 over 3? Is this a rational number? Yes, it is a rational number. And the decimal of this is 0.6666 and so on. In other words, 0.6 recurring. I have already made a video on how to change recurring decimals into fractions. Do watch that video, subscribe to my channel, and do share this channel with others, with your friends, so that you can learn the concepts together and solve the complex problems together. So now you know what a rational number is. Any number that can be written as a fraction, or if it is written as a decimal, then the decimal digits can go on recurring and non-terminating. Okay, tell me, what about 0.23? Is this a rational number? Can I write 0.23 as 23 over 100? Is it the same thing? It is. Now, is this a rational number? Yes, because numerator is an integer, the denominator is an integer, so it is written as a fraction, so it is a rational number. So you get the idea of what a rational number is. Now let's understand what do we mean by irrational numbers. In simple words, irrational numbers are those numbers that are not rational. As easy as that. But let's try to figure out. For example, all those numbers that are not perfect squares. So the square root of non-perfect square numbers, non-perfect squares, are all irrational numbers. For example, square root 2, and 2 is not a perfect square, so square root 2 is an irrational number. Square root 3, 3 is not a perfect square, so square root 3 is an irrational number. You get the idea? Square root 5 and so on. And even pi is an irrational number. Okay, a quick test of your understanding of irrational numbers. Square root 4, is it an irrational number or a rational number? Think. Is not square root 4 2? So is 2 a rational number? So square root 4 is an rational number. So this is a rational number. So basically, an irrational number is a number that cannot be written in the form P over Q, cannot be written in the form as a fraction where the numerator and the denominator are integers. So in general, the square root of a non-perfect square will always be an irrational number. And as a decimal, for example, any number that has a decimal that is not terminating and not repeating. For example, let's take a number like this, 3, 2, 1, 8, and goes on. There are no digits that are repeating itself. So this is an irrational number. So you get the idea? If the digits repeat itself, the decimal digits, it becomes a rational number. If the digits are not repeating, which is called non-recurring, and if it's not terminating, it becomes an irrational number. So this was about rational and irrational numbers. And we have understood few facts about numbers. Give a try on various types of numbers to see whether you understand, whether you are able to classify the numbers as integers, whole numbers, rational, irrational, prime numbers, cube numbers, square numbers. And keep watching the video as a revision to reinforce the concepts. Do subscribe to this channel. If you're looking for math coaching classes for board exams, you can WhatsApp me at the number given in the description below. Thank you for watching the video, and thank yourself for being proactive in learning. Subscribe to this channel, keep watching the videos, and share it with your friends. Thank you.